Okay, so our last left-hand side, right-hand side, some also carrying on with the identities involving double angles and compound angles is this one. This is what the thumb said, prove. So you cannot take it left and right, you've got to prove this. So, double angle, double angle, double angle, double angle. And the right-hand side has only got a single angle. Now, I've taught you that because I'm hopeful that maybe you're lucky, and the only thing that you write is, then maybe you're lucky. Maybe. I'm not bargaining on it, but maybe you're lucky. Right. The thing that we can bargain on the left-hand side, and everybody, including those who are battling to get a 30 and including those that are trying to get a distinction, must know the basics. So the sin double angle, no problem, because there's only one identity for it. There are only two sin cos. But you won't get 2 marks for that. You'll get 1 more, because obviously you're going to write it twice. The problem comes in with that jolly cos 2, because that has 3 different options. And you've got to decide every time that you're going to use it, which one is going to help you. Now remember, you might choose the wrong one, which you're going to manipulate again and get into something that can work. Because all of the time, somewhere, plus 1 can be substituted with sin squared plus cos squared. So say for instance you chose the wrong one and then later on made the one a plus sin squared plus cos squared, and you also got there maybe with an extra step or 2, no problem. But let's think logically and carefully and with a purpose. Remember, I would like this to just be one term and all the pluses and minuses go away. So what am I going to definitely then do?
1 minus.
You're definitely going to have to get rid of that 1. How?
By using the 1 minus 1.
Okay, so you've got to either take that which we just said, or then go to this and manipulate. Now the bottom one is the easier one of the 2, I think, to get to that plus 1 falling away. Because it's a plus, what can I substitute in the place of cos 2a so that the plus 1 will...
2 cos squared minus 1.
Are you getting this with me?
Yes.
Because it's plus, it just fell away. But then with the minus 1, also to let it fall away with this plus, what do you think? Now remember, the minus must be in a bracket, so that I'm going to have to time in here, so it's going to have to be a plus 1. So that it's minus 1 and fall away. Are you getting my manipulation of I know where I want to go and how am I going to achieve it? So if I then rather take 1,
Sin squared.
then I'm going to achieve minus 1 plus 1 falling up. But I'm not entirely sure if I'm right. And remember, later on I can always substitute stuff like sin squared, just the sin squared, with 1 minus cos squared. There's lots of stuff that you can do. And if you do it, I'm going to say, okay, mathematically that's the truth. But where are you going with this? If it's not heading somewhere, then why are you doing it? Okay, so let's simplify that so that everybody can see 2 sin a cos a. Because I would like you to show the people marking your test, which is not going to be always me, that you see how it's falling away. Happy on that?
Yes, ma'am.
The bottom is fine. Going to fall away and I'm going to be left with that. And even, you could have even started factorizing now. But why would you factorize? I would like to hear from you that you know your purpose is to get just one term, and get all the pluses and minuses falling away. And for that, you need factorization, knowing that you want to factorize. So how's my factorization going to go? I'm going to take out a
Sin.
2 sin. If I take out a 2 sin, what's going to be left? Cos. If I take out a 2 sin, plus another sin. Everybody happy on that? Now I know, and you should know, that if everything goes to plan, this had better fall away. If I'm heading for there. Are you with me? You know where you're aiming. So how's that going to happen at the bottom? I'm going to take out our 2. What's left if I take out 2 cos? Sin plus cos. Now they just swapped around, but they're exactly the same because it's plus, and plus it doesn't matter. And then I'm left with also the 2's falling away with tan, which is left hand side equal to the right hand side. And whether you leave it like that and write that as sin over cos, or take it both to tan, it doesn't really matter. Okay, the B part of the question says, for which values of A will this identity be undefined? When will this identity be undefined, but they tell me that that A that I'm talking about must be between 0 and 360, and we, in the bypassing, we just said maybe sometimes they'll include or exclude that 360. It's not extravagant, it's not something very specific, important. But then, when will this be undefined? Now the word undefined, whether I'm in trig or whether I'm in algebra, how does something become undefined? What are the rules? If you divide by 0, the denominator,
and then
what's the other way?
the asymptote. What's that thing?
Asymptotes, yes, because I am in trig, especially in trig. If there's an asymptote, because if the sum had no fractions at all, it was only 10. And I asked you, when is it undefined? When is 10 undefined?
90 or 270.
At 90?
And 270.
270? How do I write that? So 10 is undefined if
90 plus k times 180. Kids.
that's done, eh? With kids. But that will always, whenever there's a 10 somewhere in a sum, that's a restriction. If it's one of those, it's on the asymptote and it will be undefined. Right, but the rest of the sum has also got a problem, and the problem comes in when I'm busy with the denominator, the fraction. So if the denominator is equal to 0. So either for that, or then for sin 2a plus cos 2a plus 1, if that is equal to
0.
Knowing that should be with the marks here. It's going to be like a 3 or 4 mark question that we're ending here with. Knowing when it's undefined. But now I'm wasting my time a little bit. Because I've done a lot of work here that I can rather work with. Because that whole thing has developed into, okay, I'm just not going to let it fall away. So that whole bottom thing is actually 2 cos A, sin A, plus, otherwise what would you have had to do to solve this quadratic equation? Again, the double angles, again the factorizing, because it would be type 4 if it's such an elaborate thing, which you'll have to factorize, but you've already done it. So it won't be wrong if you do it again, but you're wasting time. So then how do I continue with this? When will this be 0? If, where's the 2? You can still write it, or it's just going to fall away in the next step. Because 2 times cos times the bracket is 0, so one of them has to be 0, 2 is 2. So cos can either be 0 or, agreed?
Yes, ma'am.
This can be 0. So this is a little type 1 kezi. I'm actually busy with a little kezi here as well, not quite, I'm doing just the asymptotes. And then this is also a type of kezi. Which one?
Isn't it the second one?
It's type 2 and 3 when the sin and the cos are there alone.
At the same angle.
But the same angle, so I
Divide by cos.
divided by cos so that I can get to
10.
Remember the previous one that we did, we didn't want that minus there. Is that a problem here? Because when you divide by cos, you're going to get 10, and you're going to get minus 1, which is a type 1 sum. Happy on that? So remember, the minus there was on a different sum with angles being different from each other, and then you had to manipulate to get it to a plus. It wasn't a problem here. So we're into keys. Type 1. What is mine?
90.
Reference angle,
90.
90 degrees. How do you know it? Because you know your cos graph.
Another graph.
And we have established in grade 11 that if cos is 0, then I'm actually working with the positives.
Mm-hmm.
So in quadrant 1, angle which name is A would then be 90 plus K 360. And in quadrant number 4, A would be
360 minus 90.
okay, which is 270 plus K 360. And then in this case, again we're going to have reference angle. How do I know tan equal to 1 is 45? Because you know your graphs. Right, so the reference angle is 45, tan is?
Negative.
So that's quadrant 2 and 3, 2 and 4, which I'm not writing, I'm only going to write number 2, but then with that I'm going to write K times 1, 80. So then it will be for quadrant number 2, 180 minus, and that will be 135. And 180 cares, but I already wrote it there, so it's unnecessary, but you can rather write it twice or 3 times, it's okay. And I'm done. No, I'm not done.
The specific
Because
solution.
they asked me for a specific solution because they said only between 0 and 360. Let's go to that. So specifically the A would be, let's start at a point. So when will it be undefined? It will be undefined for 90 and 270, etc. And 90 and minus 90, etc. So in that interval, it's only for 90 and 2. Agreed?
Yes, ma'am.
Let's go to this one. Start seeing the correspondence. This one will also be 90 and nothing else. This one will be 270 and nothing else. If I start minusing and plussing 360, it'll only be those two as well. And then that one, oh, there's something else. 135, agreed. If you add 180, is it going to work? 3, 1, and 5. And that's it for your answers. Please remember, if you check a memo somewhere that you got a paper from and you're checking the memo, this might have been written as only 90 plus K 180. And then you thought to yourself, no, wait, I've done this, and this, and this, and they only write this. They write, and you're right. Because they actually just put these two together. We've explained that previously. And if you're unsure, please don't try to find out why they did what they did. Just find out if you're right. How do you find that out? Check their answer by writing the specific solutions. Check your answers by writing the specific solutions, and you'll see it's the same. So don't worry about it. You can rather write 1 or 2 steps extra, and you know exactly how the process went, and you're not unsure about anything.